At its core, a neural network is really just a dumb arithmetic machine that does smart things. Imagine you're trying to build one to predict an exam score given how well you studied and how well you slept. You train it with the data you see on the left and measure how it performs with the loss function on the right. With each training row, you check how it performs by computing a loss function, which, in essence, is an indicator of how close the network is to predicting the right score. Then, go back and adjust the parameters of the network to make it better. Do this again and again and again, in other words, train it, and you'll get a working neural network that can predict test scores. Each neuron computes its value by taking a weighted sum of the activations from the previous layer, adding a bias turn to shift that sum, and then running the result through a nonlinear activation function, often a sigmoid, to produce its final output. The weights control how strongly each input matters, the biases adjust the baseline, and the activation adds the nonlinearity the network needs to learn patterns beyond simple lines. In the end, the score is just a big function of the weights W, biases B, and inputs X, and refining those values is what sharpens the network's accuracy.